In-depth exploration of one of NASA's most ambitious yet ultimately unrealized projects, the X-33 VentureStar. This story is a fascinating blend of cutting-edge technology, grand visions, and the harsh realities of engineering. Today, we'll delve into why the X-33 VentureStar, once anticipated to be the super spacecraft of the 21st century, never made it to the stars. To understand the X-33 VentureStar, we must first look back at the Space Shuttle program. Introduced in the 1980s, the Space Shuttle was a revolutionary step in space travel, providing reusable access to orbit. The program marked a significant shift from the expendable rockets used during the Apollo era. It introduced the concept of reusability in space travel, promising to reduce costs and increase the frequency of missions. However, by the 1990s, NASA was eager to take the next big leap. They envisioned a spacecraft that could dramatically reduce the cost and complexity of space missions, aiming for a future where space travel could become as routine as air travel. Enter the VentureStar. This next-generation spacecraft was designed to be a single-stage-to-orbit (SSTO) vehicle, meaning it could launch from the ground and reach orbit without needing to shed any parts. This was a radical departure from traditional multi-stage rockets and promised to revolutionize space travel by making it more economical and efficient. The VentureStar aimed to address the limitations of the Space Shuttle, such as the need for solid rocket boosters and the external fuel tank, by incorporating all necessary systems into a single vehicle. Lockheed Martin won the contract to develop the X-33, a prototype for the full-scale VentureStar. The plan was to create a technology demonstrator that would validate the SSTO concept and pave the way for a new era of space exploration. The X-33 was not just a stepping stone, it was the blueprint for the future. The project was part of NASA's broader goal to develop a new generation of reusable launch vehicles under the Space Launch Initiative. The X-33 was packed with groundbreaking technologies. At its core was the aerospike engine, a novel design intended to maintain optimal efficiency at varying altitudes. Traditional rocket engines use a bell-shaped nozzle, which works well in the vacuum of space but is less efficient at lower altitudes. The aerospike engine, with its unique design, promised to overcome this limitation, providing consistent performance from launch to orbit. The aerospike engine was designed to adjust its exhaust flow to match the changing atmospheric pressure, ensuring optimal thrust throughout the ascent. The X-33 also featured advanced composite materials in its construction. These materials were significantly lighter than the metals traditionally used in spacecraft, crucial for achieving the SSTO goal. The spacecraft's body and, most importantly, its fuel tanks were to be made from these composites to maximize weight savings and improve efficiency. The use of composites was intended to enhance the vehicle's performance and reduce the overall weight, a critical factor for achieving SSTO capability. However, the road to realizing these innovations was riddled with challenges. One of the first major hurdles was the composite fuel tanks. Designed to hold liquid hydrogen, one of the coldest substances known, these tanks needed to be incredibly strong yet lightweight. Early tests revealed significant issues. The tanks developed cracks and leaks, unable to withstand the extreme conditions of cryogenic storage and the stresses of launch. The composite materials, while promising in theory, proved difficult to work with in practice. The tanks had to endure the extreme temperatures of liquid hydrogen, which caused them to become brittle and prone to cracking. Engineers worked tirelessly to resolve these problems, experimenting with different composite materials and construction techniques. Despite their efforts, the technology of the time simply wasn't mature enough to meet the stringent requirements. Each test failure led to delays and increased costs, putting the project under immense pressure. The team explored various solutions, including new resin formulations and manufacturing processes, but none proved sufficiently reliable. The propulsion system posed another significant challenge. The RS-2200 linear aerospike engines, while theoretically superior, proved difficult to develop. Unlike conventional engines, the aerospike required precise control and new manufacturing techniques. Testing revealed numerous issues with performance and reliability. Engineers struggled to fine-tune the engines to the point where they could be considered flight-ready. The aerospike engine's complexity, with its numerous small nozzles and intricate cooling systems, added to the difficulty of achieving consistent performance. As these technical issues mounted, so did the costs. Initially, the X-33 project was estimated to cost around $1 billion. However, as delays and technical difficulties persisted, the budget ballooned. Each additional round of testing and redesign added millions to the bill. NASA, already operating under tight budget constraints, faced growing scrutiny from Congress and other stakeholders. The escalating costs and lack of visible progress led to increased skepticism about the project's feasibility. By 1999, the project was in deep trouble. The composite fuel tanks remained problematic, the aerospike engines were not ready, and the budget was spiraling out of control. Despite significant investment and effort, the X-33 was far from flight-ready. NASA and Lockheed Martin had to make a tough decision: cancel the project. The official reasoning cited the inability to resolve the technical challenges within the budget and timeframe as the primary cause. The decision to cancel the X-33 was a significant blow to NASA's vision of next-generation space travel. The cancellation of the X-33 VentureStar was a major setback for the dream of affordable and frequent space travel. However, the project was not a total loss. The extensive research and development efforts yielded valuable lessons in materials science, propulsion technology, and systems engineering. These lessons have informed and influenced subsequent space endeavors, including those by private companies like SpaceX and Blue Origin. The knowledge gained from the X-33 program has been applied to various aspects of modern aerospace engineering, contributing to advancements in reusable launch vehicles and lightweight materials. The legacy of the X-33 lives on in today's space vehicles. The push for reusable rockets, as seen with SpaceX's Falcon 9 and Starship, echoes the ambitions of the VentureStar. Advances in composite materials and propulsion technologies continue to evolve, building on the foundations laid by the X-33 program. The efforts to develop SSTO capabilities have inspired new approaches to rocket design and manufacturing, pushing the boundaries of what is possible in space exploration. Reflecting on the X-33 VentureStar, it's clear that while the project did not achieve its ultimate goal, it played a crucial role in advancing space technology. The challenges faced and the solutions attempted provided a wealth of knowledge that continues to benefit modern space exploration. The dream of SSTO vehicles may still be on the horizon, driven by the pioneering spirit that the X-33 exemplified. The lessons learned from the X-33 have been instrumental in shaping the current landscape of space technology, influencing both governmental and private sector efforts. In conclusion, the X-33 VentureStar was a bold vision that faced insurmountable challenges. It serves as a testament to the difficulties of space exploration and the relentless pursuit of innovation. While it never flew, the lessons learned have propelled us forward, bringing us closer to the dream of accessible space travel for all. The X-33 VentureStar remains a symbol of human ingenuity and determination, a reminder that even in failure, there is progress. The X-33 program also highlighted the importance of collaboration between government agencies and private industry. The partnership between NASA and Lockheed Martin set a precedent for future collaborations in the aerospace sector. Today, we see similar partnerships driving innovation and reducing costs in space exploration. Companies like SpaceX and Boeing are working alongside NASA to develop new technologies and expand our capabilities in space. These partnerships leverage the strengths of both public and private sectors, combining government resources with industry expertise to achieve common goals. The X-33 also served as a catalyst for international cooperation. The technical challenges and ambitious goals of the program caught the attention of space agencies worldwide. Collaborative efforts and information exchanges with international partners helped advance global aerospace technology. The lessons learned from the X-33 have influenced the development of space vehicles in other countries, fostering a spirit of shared progress and mutual benefit. Moreover, the X-33 project emphasized the critical role of rigorous testing and validation in aerospace engineering. The numerous test failures and setbacks experienced during the program underscored the importance of thorough testing to identify and address potential issues early. This approach has become a cornerstone of modern aerospace development, ensuring that new technologies are reliable and safe before they are deployed in actual missions. The story of the X-33 VentureStar is also a powerful reminder of the importance of perseverance in the face of adversity. The engineers and scientists working on the project faced numerous setbacks, yet they continued to push forward, seeking solutions to seemingly insurmountable problems. Their dedication and resilience exemplify the spirit of innovation and exploration that drives humanity to reach for the stars. Looking ahead, the dream of SSTO vehicles and routine space travel remains alive. The advancements in materials science, propulsion technology, and systems engineering achieved through the X-33 program have laid a strong foundation for future developments. As we continue to push the boundaries of space exploration, the lessons learned from the X-33 will undoubtedly play a crucial role in shaping the next generation of spacecraft. In closing, the X-33 VentureStar project, despite its ultimate cancellation, represents a significant chapter in the history of space exploration. It embodies the challenges and triumphs of pushing the limits of technology and engineering. The legacy of the X-33 lives on in the innovations and advancements it inspired, bringing us closer to realizing the dream of affordable and frequent space travel. Thank you for joining me on this exploration of the X-33 VentureStar. If you enjoyed this journey through space history, make sure to like, subscribe, and hit the bell icon for more fascinating stories from the world of space exploration. Stay tuned for more in-depth analyses of the triumphs and tribulations of humanity's quest to explore the cosmos. We will continue to delve into the stories behind the technologies and missions that have shaped our understanding of space and our ability to reach beyond our planet. The story of the X-33 VentureStar also serves as a case study in the management of large-scale, high-risk technological projects. The project's ambitious goals and the challenges it faced offer valuable insights into the importance of flexibility, innovation, and adaptability in the face of unforeseen obstacles. The X-33 program's difficulties in developing new materials and propulsion systems underscore the necessity of ongoing research and development investments to advance aerospace technology. Another crucial lesson from the X-33 VentureStar project is the importance of setting realistic expectations and managing stakeholder relationships effectively. The project's initial promise and subsequent challenges highlight the need for transparent communication between project teams, funding agencies, and the public. This transparency is essential for maintaining support and understanding when projects encounter setbacks. Despite its challenges, the X-33 VentureStar project also demonstrated the potential of next-generation spacecraft to transform space travel. The concept of a single stage-to-orbit vehicle remains a compelling vision for the future of space exploration. As technology continues to evolve, the foundational work done by the X-33 program will likely inform the development of future SSTO vehicles, bringing us closer to the goal of routine, affordable space travel. Looking back at the X-33 program, it's clear that the endeavor was ahead of its time. The ambitious goals set by NASA and Lockheed Martin pushed the boundaries of what was technologically possible in the 1990s. While the project ultimately did not achieve its intended outcome, it paved the way for future innovations and set the stage for the remarkable advancements we see in today's space industry. In recent years, the space industry has seen a resurgence of interest in reusable launch vehicles, driven by private companies and international space agencies. The lessons learned from the X-33 project have informed the design and development of these new vehicles, contributing to their success. The rapid progress made by companies like SpaceX, Blue Origin, and others in developing reusable rockets can be traced back, in part, to the pioneering efforts of the X-33 program. Moreover, the X-33 VentureStar project serves as a reminder of the importance of daring to dream big and taking risks in the pursuit of technological progress. The project's bold vision inspired a generation of engineers, scientists, and space enthusiasts to push the limits of what is possible. This spirit of innovation and exploration continues to drive advancements in space technology, leading to new breakthroughs and expanding our horizons. As we continue to explore the cosmos, the legacy of the X-33 VentureStar lives on. The project's contributions to materials science, propulsion technology, and aerospace engineering have left a lasting impact on the field. The knowledge and experience gained from the X-33 program will continue to influence future space missions and technologies, helping humanity reach new frontiers. In conclusion, the X-33 VentureStar was a bold and visionary project that faced significant challenges but ultimately contributed to the advancement of space technology. Its story is a testament to the resilience, ingenuity, and determination of the engineers and scientists who worked on the program. While the X-33 never flew, its legacy continues to inspire and inform the ongoing quest to explore and understand the universe. Thank you for joining me on this exploration of the X-33 VentureStar. If you enjoyed this journey through space history, make sure to like, subscribe, and hit the bell icon for more fascinating stories from the world of space exploration. Stay tuned for more in-depth analyses of the triumphs and tribulations of humanity's quest to explore the cosmos, as we continue to uncover the remarkable stories behind our greatest achievements in space.